Hi, guys, and welcome back. So now, to talk about the histology of the esophagus, you guys know that the four basic layers that we have, and we talked about every one of the layers, and we understand now why it's important to have these layers. Now, let's now talk about the epithelial lining. Why do we have epithelium? Like I said, we have it for secretion, absorption, and protection. Now, when it comes to the esophagus, I have a stratified squamous epithelium. Stratified means many layers. Squamous because these layers of cells were a lot of cells in such a way they compressed each other's. They lost all the lines between them, and they are showing as so many layers of epithelium with so many nuclei. If you guys look at this, you get to see a lot of nuclei, and that is stratified because esophagus is receiving the food, and that food is having different textures, and I really need to protect my epithelium from any damage. Yeah, so the reason why I have a stratified squamous epithelium in esophagus is here for protection. All right, and so this is basically a stratified squamous epithelium. How do we know it? I give you a small hint about how does the stratified squamous epithelium look like, but for more details about that, I'm gonna have another channel, another playlist to explain the basic histological information, which cannot be explained here into details. All right, so here we have the epithelial lining. Our epithelial lining is the stratified squamous epithelium for protection, and that is followed by the lamina propria. And the lamina propria is where you get to see the blood vessels, the lymph nodes, because we need to protect our organ from anything that's coming from the food. Yeah, think about this is as your lumen, and this is the epithelial lining, and that is followed by your lamina propria. And then you get down to see these parts of smooth muscles. Can you guys see? Again, how do you know to differentiate between the basic components of the histology? That needs to be in another video for general histology. So these are all the muscularis mucosa. You get to see a full layer of smooth muscles following your mucosa, the epithelium lining, the lamina propria, and then the muscularis mucosa. And we talked about why we get to have this in the introduction video. Now, following that, we can say that three of them are my mucosal lining, and this is actually followed by submucosa. What do I have in the submucosa? Again, it's the same idea. We get to see venules, we get to see arterioles. How to differentiate between them, it needs to be in the basic histology. All right, and you get to see glands. It looks like flowers. And how do I know that this is a gland? Because they are filled with mucus secretion, and with the histological preparations we use alcohol and ingredients that would hydrolyze all these fats, so it gives you at the end of the day empty cells, this white empty cells, but I can only see the boundaries of the cell. I can see the nuclei of the cell. All right, so these are basically the glands. And remember that I told you that the submucosal glands, we get to see them in esophagus and in the duodenum, the Brunner's gland in duodenum. Okay, so this is another hint and another nice clue that this is an esophagus. All right, so these are the submucosal glands. And as you proceed, you get to see your inner circular and outer longitudinal layers. And these layers actually are skeletal muscles. So because these are skeletal muscles, and how to differentiate between skeletal and smooth muscle, again, that needs to be in another histological video to explain the basic components of general histology. But these are skeletal muscles, and with that you will come to know that this is an upper part of esophagus, because the upper third is these muscles are skeletal, and then the middle third it's mixed, and then lower it's smooth. As you proceed to the down to the digestive system and down to the stomach and other parts of the GIT, you will have only smooth muscle, because you do not have control over these muscles. All right, and so this is the muscularis layer, and then at the end you have the adventitia. If you see the adventitia as connective tissue that has venules, arterioles, lymphatics, nerves. Okay, this is basically adipose tissue. That is gonna be your adventitia. But if you can see a layer of mesothelium, all right, that in this case you will call it serosa. Okay, so for me, I can see here a layer of mesothelium. So for that, I will call it serosa. Um, I'm not sure here why they wrote it adventitia, but anyway, you know the idea. If you get to see a layer of mesothelium lining your organ, that's gonna be the part that is covered by peritoneum. If not, then in esophagus, the part that's not covered by peritoneum, yeah, peritoneum, that is not going to be. So in the upper esophagus, we have adventitia, all right? But this is a layer of mesothelium. I can see a layer of mesothelium. And that we get to see it in an organ that's covered by peritoneum. And in that case, we call it serosa. Okay, so this is the general idea. This is a higher magnification of the same layers, again showing you the stratified squamous epithelium of the esophagus, followed by the lamina propria that you get to see vasculature, because this is by definition what we have in the connective tissue. We cannot see these things in the epithelium. We have lymphatic nodules, which is important because we are receiving a food from external environment, and I need to protect my organ. So these cells are sitting there to make sure to break down and attack any foreign molecules entering my system. And then we have the muscularis mucosae. Okay, these are the three of them. We call them the mucosa itself. All right, so these are the three layers of mucosa. All right, and then followed by the submucosa, and in that you get to see the mucus glands. Again, we have them in esophagus and the duodenum. You get to see the ducts, all right, to receive the secretions from these cells. The acini are actually the cells that are going to form the mucus, and the ducts are going to take up this and bring it by this system all the way to the lumen itself outside. And then you have all your connective tissue all around you, and then you have venules or arterioles and so on, and you have nerves, and then you have the muscle layers outside. Okay, so here is the same as the previous one, but here I have smooth muscles in the muscularis externa, and that will give me a clue that this is actually a lower esophagus, and here I can see the mesothelium. And in that case, following the muscularis layer, because we have four layers, all right, I have connective tissue, and that is lined by a simple squamous epithelium layer of the mesothelium, which is my peritoneum. And in that case, I will call it serosa. All right. So this is the difference between the upper and lower parts of esophagus. We talked about the epithelium, we talked about the gland, and this is a real histological picture. If you try to relate the nice drawings, I took it from one of the histology books, and relate it to the real picture, you will get to see again that this is your epithelium, the stratified squamous epithelium, followed by connective tissue, which is the lamina propria. And then you have these muscles. This is actually the muscularis mucosae, and that is going to be followed by a connective tissue again, which is the second layer. This is the submucosa. And then here you have the muscularis externa with inner circular and outer longitudinal layers. And then here you have connective tissue outside, and that is basically your adventitia. All right. So this is also a higher magnification to show you the stratified squamous epithelium of the esophagus. This is the lamina propria following that, and this is the muscularis mucosae. Okay, so this is a high magnification of the esophagus. Now, moving on from this esophagus to the stomach, we will have what we call the gastroesophageal junction. What happens here is that there's going to be a very huge change in the epithelial lining from the esophagus to the stomach. Why? Because in the esophagus, we are receiving food, and that food, it hasn't been digested yet, and I'm trying my best to kind of protect my organs, and that is basically more into communicating with the external environment. And any organ communicates with the surrounding or external environment, it needs to be stratified squamous epithelium. exactly like what you have in your oral cavity, and the vagina, and the lower anus, and any organ that is exposed to the external environment, it needs to be stratified squamous epithelium. And again, more details about the different epithelium and where we get to see them and why, that should be in a general histology video. Now, as we proceed to the stomach, all right, as we proceed to the stomach, we will have a simple columnar epithelium. We still have the general organization, which is the mucosa, the lamina propria that fills the folds of the stomach, muscularis mucosae, and then submucosa, and muscularis externa, and then the external layer. We still have the general organization, but if you look at a picture and you get to see a change in the epithelium from stratified squamous with those glands of the submucosal glands that you only have them in the esophagus and duodenum, and then you get to a simple columnar epithelium, you are definitely 100% sure that this is an area of the gastroesophageal junction. Okay, this is general talking. Let's proceed and see what happens in the stomach. And this is another histological picture with a special stain. This is a real histological picture to show you guys how the stratified squamous epithelium, all this blue, I think they are for collagen fibers, because this is a special stain. And this gives me an idea that this is the lamina propria, the supportive connective tissue for my epithelium. And this is a stratified squamous. And as I move on to here, this is a simple columnar epithelium. We're going to talk about now the histology of the stomach, and we're going to see how do we actually say for sure that this is a stomach, okay? But I just want to show you the transition that happens, the change that happens, the abrupt change that happens as we move on from the esophagus to the stomach. Now, this is another nice picture to show you the gastroesophageal junction, all right, here. And this is all for the stomach itself, all right? And now I want to show you the histology of the stomach. Now we are moving from the esophagus to the stomach, and we were going to see why do I have a simple columnar epithelium. Now, if you think about the stomach, now in the stomach, I have to digest the food. And in order to digest that huge amount of food, and in order to get more of cells that does my function, what I need to do is I need to expose as much of my cells as I can to the food in a small space. So what's gonna happen is I'm gonna have 3 types of foldings in the stomach and in the intestine. What are these folds? I have something called, number 1, I have submucosal folds. All right. Number 2, I have mucosal folds. Number 3, I have an apical specialization. All right. So a change in the epithelial lining itself. So what's gonna happen as I have my stomach, I'm gonna have a submucosal fold. So what does that mean? It means that this fold, my core of the fold is actually my submucosa. So here I have, this is my core, this is my submucosa, and this is the layer that's going to form the fold itself. And in that, I call it submucosal fold. This is what we call the plica circularis, okay? Now we have another folding of the epithelium, and that is what we call the velli, and these velli are there in the small intestine. Okay, here we are generally talking. We're gonna see that as we proceed, but if I find a plica circularis, or sometimes they call it valves, valves of Crick-Ring, sometimes they call it intestinal valves. All right, so all of these are the submucosal folds. Here they call it the rugi. Okay, so this rugi is basically the submucosal folds. It means what is folding here is everything you know above the submucosa. You guys know now by now that we have 4 layers, right, in the GIT. I have the mucosa with its 3 layers. I have the submucosa. Basically, what is forming here, these folds, is starting from the submucosa itself. Okay, so this is the mucosa, this is the submucosa, these are the folds. Down to this, I have the muscularis and adventitia. These are down, they are not folding. All right. Now, this is the submucosa, and above that, I have the 3 layers of the mucosa. And in the small intestine, other than this fold, okay, the epithelium, the mucosa itself. So if we said that this is the one that folds here, the mucosa itself is going to make another kind of folds, which are the villi. Okay, so this is when my mucosa, the black line here, makes another fold, forms this vellus, finger-like projections. Okay, so in that, I'm trying to expose more and more of the cells. In each one of the villi, these villi are lined by columnar cells. Now, if I blow up one of these villi, like if I try to take one of the vellus, I will see that this vellus is lined by simple columnar cells, right? Simple columnar cells. Now, if you look at these simple columnar cells and you take one of them here and think about it, you will find that this columnar cell is also having another kind of folding, which is what I call the microvilli. So this is another foldings of the tract, and this is in the apical specialization. It's a special thing that happens on the apical surface of my columnar cell, and this is also to increase the surface area, and this is also to improve absorption and expose my cells more into the lumen and make use of what I'm having in the lumen and digestion and absorption and everything by exposing more of my cell into the lumen. All right. So I want you guys, when you hear the word veloi, plica circularis, microvilli, I want you to understand what is actually that. Why do I have them? And what's that to do with the digestion and how do they form? So think about it this way. You have foldings, and the more foldings you have, the more function you can have in a small place. All right, other than the coiling of the small intestine itself. So imagine the amount of cells that are working in your small tiny abdomen with all of these coils, with all of these submucosal folds or plica circularis, with all of these mucosal folds, which are your villi, with all of the folds of the apical surface of your single columnar cell. Can you imagine how many surface areas are exposed to your food to get the maximum kind of digestion and absorption that you can in your abdomen from the food? So can you see the structural functional adaptation of your organ into how you adapt to the function based on the structure you have? Okay, so this is a very important concept that you guys need to know before you proceed into the rest of the GIT. And let's go ahead and see what types of cells do we have. If you look at the stomach and you see that in the stomach itself, you have your simple columnar cells, and that is what we call the gastric pit. Okay, they kind of fold, they make foldings, because here I need to have a cavity that will receive the nutrients and that will receive the enzymes from all of these cells into here, and they were gonna take them all the way to the lumen to get exposed to the food itself, to do the absorption or to do the digestion that I need. So if you look at the upper part of my histological section in the stomach, I will see what I call the gastric pit, and down I have the gastric glands. All right, so here I have gastric pit, and here I have the gastric gland. So what is the difference? In the gastric pits, this is actually your surface mucus cells. They are important to secrete mucus that will help me to protect, to digest the food, to protect my epithelial lining from mechanical and chemical injury. So it's very important to have mucosa up there. Now, down, I have the gastric gland itself. So I have gastric pit, and down I have gastric gland. This is the gland. What does gland mean? It means the cells that are going to secrete enzymes to help me to digest the food because I am here in the stomach. Now, what kind of cells will you see in the gastric gland down? We have many types of cells. The most important ones you need to know are the enteroendocrine cells. They are important to release the hormones that will control the digestion, like gastrin. And once you get the gastrin, for example, it means that this part of your stomach feels that there is food and we are digesting the food. So that hormone will go ahead and communicate with the other cells in the duodenum and tell them to get prepared for the next stage of digestion. Okay, so to proceed the digestion and take you to the next level there, and then to release the cholecystokinin, and then from there you get to have so many things that happen in the duodenum itself to digest the fat. And I explained that in the gross anatomy of the extrahepatic biliary system. You can go ahead and watch it. Okay, and then you have the most important things I want you guys to know is the chief cells and the parietal cells. The chief cells are the principal cells of the stomach. It's why I have a stomach. It's because these are going to release the pepsinogens that are going to break down the proteins in the stomach. Now, I have pepsinogen, which is inactive, and as these cells produce the pepsinogen, these enzymes are going to go out, and as they go ahead and reach the lumen of the stomach, thanks for the parietal cells, once they feel that the pepsinogens are coming here, they are going to release HCl, and that HCl is going to come to the lumen, that the HCl is going to activate the pepsinogen, all right, and converted into pepsin in the stomach, in the lumen of the stomach itself. Because if the pepsin was released inside the gland itself, it would have broken down all the stomach layers. Okay, so thanks for the parietal cells that they are going to activate that important enzyme whenever I'm ready to digest the food in the lumen. Okay, so these are two important cells that you guys need to know. Other than that, you have the mucus cells, enteroendocrine cells, we cannot really see all of the cells in the regular histological section, but the chief cells and parietal cells, we can see them, and they are important to be identified. Now, let's look at a drawing that shows you the epithelial lining, which is basically your plica circularis, and how your mucosa is folded with all these layers, the epithelium, the lamina propria that has the glands and so on. And then you have your muscularis mucosa down that wraps around everything. And here down, and you have the gastric pits and you have the gastric glands down. And of course, you guys by now know the different layers, the submucosa, muscularis, and everything. I'm not gonna talk about that. I just want to talk about the gastric glands now. So let's proceed and see how the parietal cell is actually, it looks like a fried egg sunny side up. Okay, so as if you have a fried egg sunny side up, this is actually how the parietal cell, all right, that secretes the HCl looks like. And we have them near to the lumen because here they were going to sense that the pepsinogen that are at the base of the glands, and they are actually basophilic and they look bluish, they're going to send the pepsinogen. And as I proceed up, these cells are going to sense that and secrete the HCl to the lumen, and here I'm going to activate the pepsinogen. Now look at how the parietal cells again look like a fried egg appearance, and they are acidophilic. They are kind of reddish, and in a real histological picture, they are kind of pale. But if you look at the chief cells, they are basophilic. I'm going to show you in a real ones now, because now you know the idea, guys. Look at this histological section. If you look at the stomach, and you have all your foldings of the epithelium, the mucosal folds of your stomach, and this is your gastric pits, and here is your gastric gland. If you guys can see any pale staining cells in the gastric glands, think about your parietal cells, okay? And you know the function of that. If you guys see any dark staining cells, you need to think about the chief cells, okay? And now you know the function of that, and that is basically followed by the lamina propria and everything else. So this is how you will know how to identify the different cells. And here another one. If you guys look at the, hold on, if you guys look at this, the rugi of the stomach, the submucosal fold, so what's in the core here is the submucosa. It's not the lamina propria. This is different than the veloi. You're going to see it in the small intestine, okay? Because this is a stomach. Here I have these dark things. This is all the mucosa, but my core is submucosa, okay? If I look at a higher magnification, you guys know that the gastric pits are lined by the mucus cells. It means that I can see white things. I can see cells that are losing their content, because remember, in histological preparation, we kind of lose the fat, the mucin, and the glycoproteins in my cells, so it looks like white. Okay, so these are all the gastric pits, but down here I have my gastric glands down in the stomach, okay? So and then we have the glands themselves down, okay? We have the parietal cells, they are pale staining, and then we have the chief cells, which are darkly stained. Yeah, okay, so these are all parietal cells. So this is another picture. Now, we talked about the stomach, and now we are moving on to the pyloroduodenal junction, and how after having these, the lining epithelium of the stomach, we're gonna see another important foldings of the mucosa itself with a core of lamina propria, and this is the velli. And once you have a change of the epithelium from just submucosal foldings to submucosal and mucosal, which is giving you the vellus, the velli, finger-like projections. Think about it as if it's your finger like projections. Okay, these are your mucosal foldings. All right, so it means now you are moving on from the pylorus, because the pylorus is the last part of your stomach here, and you are moving on to the start of the duodenum. And we're going to talk about the this is again an abrupt change, and by now you know that this is this is your stomach, and here you have vellus. Well, actually this picture is not the best, but the core here is lamina propria. The core here is a connective tissue, which is dots of lymphatic cells and connective tissue cells inside. Okay, you guys can search on Google and look at more pictures. Hold on, I think this is a better one, but anyway, by now you know the structure of the stomach, and in the next video you're gonna see the structure of the small intestine, and you will be able to identify the junction itself, because when we talk about the organ itself in details, the junctions is going to be easy. By now you know how the stomach looks like, you know how the pylorus part of the stomach, its general organization, as we mentioned. And in the next video we're going to talk about the small intestine with its three parts and how to differentiate between them, and by that you will be able to know that junction. See you guys, thank you for watching, and see you in the next video.